Let's consider this question. This question comes from work and energy. So in physics, you said energy, the ability to do work. Yeah, so let's look at this question. I'm saying the figure below shows a stone of mass 2 kg which drops from the top of a cliff and it takes 2 seconds to strike the ground. Acceleration of free fall is equal to 10 meters per second. So you have this diagram here. That was that stone which was on top. There was a height there which was not mentioned. Although the cliff and the stone which was on the ground there. The first question says, name the form of energy possessed by the stone before it falls. B. Determine the height h of the cliff. C. Calculate. C. Roman numeral 1 saying they calculate the kinetic energy of the stone when halfway down. H. C. Roman numeral 2 the final velocity of the stone as it strikes the ground. So the first thing, let's write the data that we have. You can say data. What do we have in our data there? They're saying mass. Mass, we have 2 kg. What else? Acceleration due to gravity. We have 10 meters per second squared. What else do we have there? We have time. Time, it takes 2 seconds. So time, we have 2 seconds. This was the time. What else do we have there? Height, we don't have. Now the question is saying, the question A, they are saying, name the form of energy possessed by the stone before it falls. So before it falls, this means that it was not moving, it was just constant. And the energy that is there, it's potential energy. Potential energy. That's the energy that was possessed there. That was potential energy. It was potential energy there. But when that object starts moving, or that stone, when it is released, when it is in its motion, this we're going to say it acquires which energy? It's kinetic energy. But in this form, it was not moving. It was not dropped off. It was at rest or constant motion. This means that the energy that was there, it was what? Potential energy. Question 2, determine the height h of the cliff. So, another thing that you need to know when finding height, don't forget those linear equations, because we have them. If you remember, we have v squared is equal to initial squared plus 2as. Another one we have, it's s is equal to ut plus half at squared. Another one is velocity equals initial plus acceleration times time. So on this question, they are saying the height. This s there means height or distance. If you want, you can say h. If you want, you can symbolize it as x, or s means the distance. Even this one is s as well. Now, according to our question, they are saying find the height h. So when we look at our data that we have time. When you use this formula, you're not going to work because you don't have what? H, or the height. So let's consider this and this one. This one you can't use it because the final velocity of which you don't know that velocity, but initial you know. In fact, here when that object it was at rest, the velocity that was there, initial velocity, it was 0 meter per second. Yeah, so under free fall, if you check the notes that I sent in the group, that's what it says. Now so the formula that we're going to use there is this one, because we want h the distance or height. Initially there you have 0 meter per second times 2 seconds that we have been given. Acceleration due to gravity we have there. Time or we all have there. So we can say B. This one, if you want, you can say H is equal to UT plus half of acceleration times t squared. Then you can say H is equal to, initial it's 0 times, what's the time? 2 seconds plus half of acceleration due to gravity, it's 10. So here if you want you can use G. See, acceleration due to gravity. There you can use G if you want, just the same. So we're going to say half times 10, which is acceleration due to gravity, this one. Then time, we know it's 2 squared. We can say H is equal to, this one 0 times 2 is 0 there. Just forget it. Okay, just write it. 0 plus 2 into 10, it's 5 there. Times 2 squared, this means we multiply 2 times by itself. We're going to get what? A 4. Then we can say H is equal to this 5 times 4, it's 20, plus 0 is 20 meters. This is our height. We together there. So that it was 2 marks. Question C is saying calculate the kinetic energy of the stone when halfway down. So when they say halfway down, remember the formula for potential energy. Potential energy is mass, gravity, acceleration due to gravity times h. Then kinetic energy, we can say half of mass v squared or final velocity squared, this. So when they're asking that let's find the kinetic energy of the stone when halfway down, remember what we said. We said this. Let's say this, the height of this. Okay, in that question we have found that our height is what? 20 meters. So we say that there, when that stone was not released, that was at constant height, this energy that was potential energy. But when it started moving, going there, reaching in between of this halfway, we can say potential energy there is equal to what? Kinetic energy. But when that ball reached on this ground, we can say there was what? Kinetic energy. So now we can use the conservation of this energy, that the energy when it is halfway, the potential energy is equal to what? Kinetic energy there. So since kinetic energy is this one, we don't have final velocity, so we're going to use potential energy by saying potential energy is equal to mass, acceleration due to gravity times height h. Then we say this mass we have 2, gravity we have 10, height we have 20. When we multiply this, what do we get? This is 20. 20 times 20 is 400. 400 joules. Don't remember the units for energy. Now the question was saying the final velocity of the stone as it strikes the ground. So this was the potential energy of that stone when it was on top. But this kinetic energy there, no, I think here I just made a mistake. You can say it's half, is equal to half of what? Kinetic energy. You can say potential energy there, it's what? Half. So that I can just say this. So where potential energy is equal to kinetic energy is this way. There was potential energy. So that potential energy that was there, it's equal to what? To kinetic energy, which is here. So but there I can say half of potential energy, that's going to be what? Our kinetic energy. So therefore we can say kinetic energy is equal to I'm going to say it's potential energy divided by 2. So what potential energy do we have there? The potential energy that we have there, we can say it was 400 joules divided by 2. This one you can say it was 200 joules. That was our what? Kinetic energy. So that question what? C1. This is C number 1. Then question 2. They are saying the final velocity of the stone as it strikes the ground. So the final velocity there. So if we remember, I said the potential energy which was there is equal to kinetic energy, which is here. So on top there was this kinetic energy, which is 400 joules. So this means that even there on this ground there, the kinetic energy also was what? 400 joules. So we can say kinetic energy is equal to half mass v squared. We want to find the final velocity. The kinetic energy which was on this ground, it was what? 400 joules equal to half times what is the mass? It's 2. Velocity squared, the one that we are looking for. So here 400 is equal to, when you say this divided by this, it's 1. 1 times v squared is v squared. Then there can you complete the square to both sides. You can say 400 square root of 400 is equal to square root of v squared, so that this square root goes with this 2. So just remaining with the v, you can say v final velocity, you can say square root of 20. Square root of 400, it's 20. Then you can say v is equal to, since it's velocity, you can say 20 meters per second. So these were the solutions to this question that we had there. Thanks. If there is any question, you can ask in the group.